Good afternoon. My name is Usman Shakeel, and I'm a solutions architect lead for media entertainment at Amazon Web Services. Today, I'll be talking about linear broadcast distribution on AWS. My partner in crime, Konstantin Wilms, couldn't make it here, unfortunately, but we worked together on this particular concept along with our customers. So a lot of you might say that, really, is it linear broadcast distribution on AWS or is it really contribution? And specifically, it is using IP networks at the end of the day, right? So we'll be talking about linear broadcast delivery to affiliate networks. Some of the use cases include electronic news gathering, live sports events, etc. And the way it's really started was that basically a customer asked us a question that can this really be done in terms of, that they were interested in finding out if there are alternatives to the traditional linear video distribution. Then another customer came about and, asked the same kind of question. So, pretty interesting how these things come about. And so Amazon Web Services being really customer centric, customer focused, and really happy to be a part of that. We work very closely with our customers. That led us to think, and we talk to our customers more, try to understand the problems, the challenges, the issues with this workflow. And customers told us that any solution that we come up with will need to maintain a very low latency and a very high quality. So quality is one thing that they cannot really compromise at. So they had already looked at CDNs, other codecs, and the issue with that is the HTTP transport models. Really, the latency between 6 to 30 seconds plus doesn't really work. It's unacceptable. And if you want to decrease latency, you decrease the quality, basically end up compromising on the quality, and that's not workable either. So the other thing they mentioned was that there was a lot of pushback on cloud technology, especially over IP networks, because fixed pass or MPLS type of delivery can cost an arm and leg, basically a lot of money. Cost is a big concern. And so they wanted to really replace something that they had, but they wanted to make it better. And some of the reasons they told us why. The biggest one being capacity. They were at maximum capacity in terms of their infrastructure, the data centers that they had, and they wanted to increase the number of distribution channels, and they wanted to utilize their codecs, higher bit rates, and they wanted to do data delivery or processing over the same sort of channels. And if you look at it, the satellite capacity can be used for video as well as data casting, and if you're taking files and IP multicasting them over the satellite, you have to really opportunistically distribute your data. And you could distribute live as well as VOD, and live is always going to take precedence over it. Now, imagine if you have a minimum, say, 10 megabit capacity. Maybe you can have two low bitrate high def streams, maybe say 3 megabit a piece, somewhere around 7 megabits already. And with the adaptive bitrate, the channel may be open up, and you can use the channel opportunistically to transport VOD or data set as well. But then you have to carousel it, putting some kind of FEC, forward erasure correction, so that all the packets are received on the other end. The customers also were one of the reasons they were also looking at it was also that they wanted to have additional HD channels, say, going over the same network. So that led us to think, and we started whiteboarding and thinking about what can be done, what are the different challenges. So let's start with some of the challenges here. This is your traditional multi-hop satellite distribution. And this is widely adopted today, right? And there can be multiple different permutations of this architecture. There could be multiple satellites on either the hop, the backhaul, etc. You could have multiple, obviously, spokes, decoders, or affiliates across, geographically dispersed. And obviously, the field source encoders could be many of them. So, but for the purposes of our discussion, we're going to keep it very simple. This is a very simple multi-hop satellite distribution model, right? Again, goes to the use case of electronic news gathering scenarios. And the frequency channels have a specific bandwidth. We all know that. And there are yearly contracts that are in place, and you can't really add bandwidth on the fly. That's the biggest challenge today that, yes, you can say, well, I can go add or buy additional bandwidth, but how long it's going to really take realistically to procure it, provision it, and become available. So let's examine this model a little bit in more depth. So first of all, as I talked about, this is a static infrastructure, right? And it's purely CapEx based. So broadcasters will look at new codecs for more compression, but that means that they have to adopt new technology or upgrades at each edge. And we talked about there can be multiple edges, there could be multiple spokes, head ends, etc. So every single time they want to look at a new codec, that means pretty much a technology refresh. And while web-based delivery may move onto new formats like WebM, but it's not necessarily feasible in this model, right? And on top of that, there is year-over-year cost drops for transit and storage with the new technology coming out, new infrastructure technology coming out. So what you see is this sort of constant cost versus capacity churn that the broadcasters find themselves in. And from a long-term, and it's a really long-term investment that they have done because they are in these yearly contracts with either the infrastructure provider or the satellite link providers, etc. So in terms of their workflows, they're really not agile because, again, going back to the lack of flexibility in terms of the way these things works today because of the static infrastructure. And you can't really change the configurations. It's not really easy. And anytime you want to try something new, it's pretty much a new sort of, say, infrastructure that is being bolted on top of an existing infrastructure. That makes things even messier. Then there are service contracts. There are end-to-end systems and carriers that push back on it. And so the customers, they find themselves stuck in pretty much in a legacy type of a model, right? So in our scenario, we had a customer that was pretty much just stuck with SD while the rest of the world moves over to HD, right? And one of the things that we probably all of us know, when DTV first came here in the US, the first encoder was 16 megs. And so the stations, they wanted to get more and more channels, and they started really disseminating the content. And everyone is probably familiar with the video quality that ended up being like a lot of pixelation, and there was really no space for more channels. So only one single HD channel and multiple SD channels, and they sacrificed quality due to limitations of bandwidth. And back then, in the 90s or early 2000, there wasn't really any way to distribute this content over internet at scale or MPLS. So hence the issues. The other set of challenges is that the distribution is constantly evolving. So the whole workflow is evolving, right? Our customers, they want to target different devices, mobiles, handheld, multiple devices. But from a station level, it is very hard. Stations are owned and operated and sometimes a part of affiliate network. A lot of times they are dictated, so it is very fragmented across a distribution chain. And it kind of translates into a more data center type of problem, or at least they perceive it to be, right? Where they are building more infrastructure to serve more devices, more affiliates, more consumers at the end of the day. But it's actually making an existing problem somewhat more complex and worse. So that's where the flexibility, scalability, agility, and the geographic distribution of the cloud really shines, and we'll explore how. But I just wanted to at least point it out here. Additionally, the workflows are becoming more and more complex. We see a highly iterative ecosystem, more and more formats, resolutions, etc. And new technologies have their own set of problems, right? These all can be very easily addressed by a centralized cloud model, and we will explore that. And there is constantly, a growing target device landscape. We already talked about it. So let's say if your workflow is built on WebM, let's say, and it goes out of use, then how are you going to go and change your environment? In the case of the cloud, say if you have your infrastructure, your environment built on this sort of say kind of disposable infrastructure model, right? Where say you're working on a POC or any type of an environment that you're testing out, it works great. If it doesn't really pan out, you can terminate it. You don't have to pay for it. You're not really tied to it. And in addition to that, so agility is one key thing that cloud brings to the table. But in addition to that, really the durability, reliability, throughput, and latency improvements that the cloud also brings to the table. So basically purely from a scale perspective, if you look at it, and from a high availability perspective. And in addition to that, it's not just about pure infrastructure. It's also about the sort of up the stack utility services, automation, that templatization that are provided to you free of charge, basically, that make this even easier, that you can have a POC environment, test it out, really harden it, take it as a template, deploy it at a much larger scale, at a much global basis. So, just like anything else, there are obviously perceived limitations. People have perceptions. How's this thing going to work? First of all, it's IP delivery. It's on the cloud. That means sacrificing media quality. Well, not necessarily, because, you can adopt newer codecs. So instead of, say, pushing 11 meg MPEG-2, you could be using H.264 and pushing 3 to 4 megs. Now, the second thing is adopting non-traditional protocols. Well, if it's over IP delivery, how are you going to deliver the HDSDI formats to the existing infrastructure, right? So really, if the second hop is under your control, then you can adopt through transcoding. IP-based decoders can be interfacing with newer protocols. So basically, your decoders and coders, while they are communicating with each other over IP-based delivery, in the back end, they are producing HDSDI formats that your other devices can hook up to. And I talked about dev test environments that are easy. That talks to the cost of new distribution networks or ability to scale without impact, because now you can really automate. You can really templatize your environments, test out everything works great, and then scale it out for game time or say for a very large scale event. And latency really is, well, actually, let me take a step back. In the case of talking about the ability to scale without impact or cost of new distribution networks, if you look at it in the satellite space, you still have to buy simulation equipment, right, which is going to cost as well. So at the end of the day, if you do the comparison, there are a lot of tools that and since the fact that you're not really tied to, say, one specific infrastructure, it makes it a much better proposition. From a latency perspective, latency is not really a concern, because you can use direct connect or MPLS type of connectivity directly into the cloud as well. And general increase in complexity, as I mentioned, you could really templatize these things, and it makes it like the utility services provide you a lot of tool set in terms of automation and testing. But the biggest of all these, the biggest perception is broadcast distribution scales infinitely. But is that really true in the case of, say, affiliate delivery? Not so, because you have finite number of affiliates that you're going to be delivering to, and then you can really scale for and plan for the specific amount of bandwidth that you're going to need for that. And based on that, you can scale your direct connects or MPLS or whatever type of connectivity that you need beforehand. The other thing is, can we implement a solution that's not really changing the fundamentals of transport? As I talked about, if you want to be able to transport HDSDI feeds all the way from a field encoder to the affiliate decoder, how do you do that? So, and that also adds to the fact that you want to really preserve the frame rate and picture quality so that there is no sacrifice in terms of the quality of the video that you're delivering. And as I talked about, if it is, say, cloud-based encoders or decoders, then basically they are interfacing with each other over IP networks, whereas the input and output could be HDSDI. And then finally, can we scale for at very low cost? So again, given the fact that if you have a fixed number of affiliates, you know how much bandwidth, what is the type of say bit rate you're going to be delivering at, and based on that, you can scale, you can architect a solution which is highly cost effective, and not just cost effective at a specific way, but since it's all templatized and it has the capability to auto scale, the template is cost effective. So it doesn't matter how big it grows. At the end of the day, that cost effectiveness that is built into this architecture kind of scales out as well. So in a non-cloud solution, how would you really do it? I mean, you would really need to have multiple data center footprints. You're going to need high-speed, costly IP transit, and local operations staff to take care and maintain your data centers. And it's a massive capex outlay at the end of the day. It requires a lot of money. And even in terms of setting up the data center, it's not an easy thing. So why do you want to do that, right? When AWS takes care of this undifferentiated heavy lifting at the end of the day for you. So you focus on what is your core business and not this data center stuff, right? And let AWS take care of it for you at scale at a very cost-effective proposition. So let's dive into a few noteworthy benefits that the AWS cloud brings to the table in this specific case. So first of all, the global distribution footprint. So today we have 11 different regions, including China and Frankfurt, the latest ones that we launched, regions in North America, South America, Europe, Asia Pac, Australia, and China, as I mentioned. So the idea for the regions is that each region is composed of multiple data centers. So you can have at least 2 or as many as 4, in many cases, data center availability zones, we call them, which are clustered of data centers within a region. They are physically separate entities, meaning they're physically separate buildings, even different power sources, different ISPs in many cases. So the idea is that you can build applications that are highly available while staying in one single region. So how does this help in this whole challenge that we have? Basically, first of all, regions allow us to expand a hub and spoke type pattern to distribute a source over a given geography across the world. First of all is that, right? So you can use any of these regions, not just from an ingest perspective, but from an egress perspective as well, right? So think of it as you're going to spin up an environment which is closest to your affiliates or closest to your field encoders so that there is a very low latency type of a connectivity. Secondly, the availability zones I talked about, or the clusters of data centers within a single region, give you the capability to build a very highly available type of an environment. And it's highly scalable. So if you need more bandwidth, no problem. You just spin up additional instances, EC2 instances, and you get additional bandwidth. And you're not really tied into, say, a specific bandwidth that you bought. It's pay-as-you-go type of a model. You can do direct connect into specific regions that you're interested in, and that gives you basically jitter-free, low latency type of connectivity. You can do one or as many as you like, from 1 gig all the way up to 10 gig type of private circuits into AWS. And the direct connect also gives you the ability to utilize cross-continent satellites and backhaul using patterns for existing downlink locations over MPLS to local direct connect enabled facilities. So direct connect enabled facilities are all over the globe that we have. And let's say if you don't want to use direct connect, many of these regions, specifically the ones within the US, anytime you are moving content from one region to another region, it's over Amazon backbone. So the second piece is massively scalable compute. So AWS Elastic Compute Cloud, or EC2, gives you the capability of spinning up the instances that are specific, have a specific set of cores or CPU, memory, I/O. If you want to use a GPU, you can use a GPU as well. We have G2 instances, high storage instances. So you're not really, say, black boxed into one single type of instance from, say, a CPU core or memory or network perspective. There is, as I mentioned, multiple different families of the instance types. Within types, there are sizes that you can use and really leverage for your application. How much network are you going to need? How much CPU cores are you going to need? How much memory you're going to need? So based on that, you can spin up those EC2 instances very, very quickly and pay for really what you're using. So this is highly, attractive. And this one is very attractive as well. The concept of infrastructure that is specific to your project, or the scope of it is for your project. So think of it as a sort of like a disposable infrastructure, right? So you're not really having these fleet of servers or instances, virtual servers running forever and managing them. You basically spin these up as you need them and terminate these as once your stuff is done. So in this case, we have an Amazon machine image and CloudFormation template. So CloudFormation template is a way to templatize your entire AWS environment. So think of it as your entire ingest layer, your entire encoder layer, your entire egress layer. Everything can be templatized, parameterized to scale appropriately. You do your job. You can either scale it down or simply call the CloudFormation terminate stack, and it goes and deletes every single resource that you have created. So the idea there is that you don't have to keep paying when you're not using your infrastructure. Then we talked about codecs and new technologies, and how do I kind of deal with that? Because if I am buying licenses, I'm kind of stuck with that. So AWS has a pretty attractive ecosystem of partners, and a lot of these solutions are actually available in the hourly licensing model or bring your own license model. So AWS Marketplace is actually a marketplace of the software vendors that are available, as I mentioned, in the hourly pricing. So all you do is you just simply go there in the AWS Marketplace, select the appropriate or the specific software that you want to launch your instance with, select the instance type and click go. And it's included, the hourly license is included in the hourly running price of your instance, which is very cool. So let's take a closer look at the problem now based on the feature set that AWS brings to the table, some of the challenges that we discussed. So again, looking at the traditional model, let's say first of all, what if we evolve the second hop here? Right. So the approach is that for uplink and downlink, we can use dedicated internet-based IP net links. We can use direct connect for uplink or for stream consumptions. The biggest concerns are how do we handle or how do we manage the forward erasure correction or FEC, and the other thing is the latency. Right. So satellite latency is around 500 milliseconds for up and down. Plus, if you add, say, additional things in the chain, it's somewhere around 1.5 seconds. At least that's what our customer tells us from the electronic news gathering. So if we can do any better than that, I think we're game. So basically, this is the approach that, as I mentioned earlier, we use direct connect for uplink and downlink. And we can actually have multiples of these AWS environments across the globe, depending on where we need to transport this stuff, right? Or where the field encoders are, where we are getting the ingest from. And we can use Route 53 latency-based routing, which is basically your affiliates can go to Route 53, which is our DNS resolution service, and it will point them to the least latency-based route for the AWS environment for them. So in that way, you're getting that automated sort of, say, latency thing built in that takes care of it. So can we benefit the first hop as well? Maybe. As I mentioned earlier, you can templatize your environments. First of all, you can, if we have all this thing templatized for the second hop, it's very similar sort of a methodology in the case of a first hop, right? So basically take the same patterns from there, apply to the first hop as well. Maybe your headend can become a cloud-based headend. Again, we talked about Route 53 latency-based routing and some of the applications there. But some of the things that are going to come into play, like, for example, bandwidth and transport, how do we handle that? So let's do a quick comparison, right? So in the case of satellite, what you're going to see is, or at least, again, what our customers tell us, costs somewhere between, say, $3,000 to $5,000 a month per megahertz channel, and say about $30K for a 20 megabits stream. And there is the satellite capacity lease, and plus obviously the spoke cost. So anytime the affiliates, they have to pay as well, right? From a bandwidth perspective, and there are multiple service contracts as well. If you look at on the AWS model, basically I just took the 20 megabits per second, running 24/7, however many bits transferred out of the cloud, just multiply it to the egress rate that we have, comes down to somewhere around $500 a month. So obviously, then you add how many affiliates and you multiply with that number, but that is kind of, say, in the same comparison that the affiliates have to pay if they're going straight to satellite. FEC can be implemented on UDP layer using ARQ or SRT for jitter, latency, reliability perspective. And one key thing also is that we also last year launched the sub 1 gigabit connections for direct connect. So you don't really have to have 1 gig for every single connectivity, direct connectivity into AWS. You can go as low as 100 megs, right? And then you can have multiples of those to give you the one-to-one type of a redundancy or scalability. So it's a pretty good proposition from that perspective. On the hub and spoke side, cost, again, uplink and downlink link equipments in the case of, say, for example, Dish, LNBs, they're expensive versus IP network equipment. Processing equipment has to be duplicated at every single facility if you're going with a physical model, whereas in the cloud model, it's just simply the flexible licensing model as well as the templates that I talked about. And last but not least, content and processing gravity. That's a very important piece, right? Because moving the content around is very hard. It carries gravity with it, and same actually goes for processing as well. And that's where the AWS ecosystem or the feature set and services that we offer come into a great use. On the receiver ecosystem side, it's highly fragmented, it's costly, and it's uncoordinated, and there is lack of agility. The reason being, there is duplicate hardware that you're going to need for B2B proxies and media processing. And then B2C spoke content has to be pushed through CDNs, and CDNs don't really provide custom workflow implementations. So there, again, you're kind of stuck in this sort of like a black box. So let's revisit our original topology now. So taking the multi-hop satellite distribution again, this is what we came up with. So we can augment our second hop or even outright replace the second hop, right? We can add new functionality maybe to the first hop, but let's say for the second hop specifically, we can provide low latency, high throughput, direct connect, secure VPN or standard source IP restricted ingest points, depending on the source. Also note that there is the cellular connector is actually feeding the main infrastructure we plumbed up. But there is no reason we couldn't segregate infrastructure to make it more secure. Infrastructure can be well-defined, highly available, and easily scaled via CloudFormation templates, as I talked about. And we can provide better than one-to-one redundancy. It could be one-to-many, right? And the idea is that it just simply scales out. And as I talked about earlier, Route 53 can provide latency-based routing to the virtual headends or cloud-based headends to the affiliates. And then the headend hardware is replaced with easier-to-manage IP transit encoders, and CPE equipment on-prem is largely removed. And this may open up budget, for example, for spoke content caching, storage processing in the cloud. We talked about content gravity, right? And all of this can be tuned on a per customer basis, depending on the required workflows. So again, this is a highly flexible model And different affiliates can have different requirements, et cetera, so on and so forth. So again, going back to it's not just for, say, affiliate transfer or delivery, right? You have to look at the bigger picture. Now that you're using the cloud for your delivery, everything can be stored in Amazon S3 or your object store. And I gave a talk yesterday on 4K media workflows on the cloud. And the whole concept of, I call it the content lake, right? So think of it that it's a big area, big storage space, which is sort of, say, an infinite storage capacity that you keep dumping all your content into. Doesn't matter what resolution, what format, what is it, right? And let the other processing or consumers or applications really scale based on the workflow needs. And that's where this thing is, really, that even in this model, you can throw it in S3 and then go from there. Some of the notable features, first of all, highly scalable infrastructure. Talked about it in several other slides already. But the idea is that you can capacity plan for live HD streams and contribution silos. There is low latency and high throughput. And obviously you can combine with regional replication on Route 53, which in a true nearest neighbor latency kind of a thing. Also, this is another sort of, say, application that came out of it working with our customers. That is that you're doing encoding, you're doing ingest via direct connect on a standard instance type. You want to do GPU transcodes, you can do that, push stuff into S3, and then deliver HLS with CloudFront or any other CDN for that matter. Media lifecycle management, again, the content lake in action. Really, you putting stuff in S3, but then you define lifecycle policies that automatically your content, which is, kind of, say, old content, automatically trickles down into a very cost-effective, low-cost archival service, giving you the same amount of durability. And the benefit here is that everything is accessible through a single API. So your applications keep working as they are without even knowing which storage tier your content lives. And it just works, and it manages. It's automatically cost effective from your from that perspective. So yes, it's enough said. Talked about a lot of things on paper on the slide. Is it real? Really, right? So we actually did do a proof of concept with a customer. And here are some of the results what we found. So first of all, deployment perspective, it was very easy. We deployed it in one afternoon into an AWS VPC. We coordinated cross-country with multiple head-end operators, encoder, decoder manufacturers, and we delivered 6 megabits, 1080p, MPEG UDP with FEC stream. We distributed it over public internet, did not even use direct connect in this implementation. And what we found was 200 milliseconds encoder to AWS and AWS to decoder latency. So 400 milliseconds total. If you add additional overhead to it from, for additional processing, etc., it was still under a second. So very low measured latency, even if you compare it to this, the second hop in the case of the satellite. In terms of high availability, the system's been running for about over a month now, and with 100% uptime with no video dropouts at this point. All right, so let's go shoot the bird. Thank you very much for the time, and we will be at the Innovate show.
Alrighty, any questions?
Guilty if I don't ask it. Feel guilty if I don't ask. So, and this may be a broader question. So, given that experience and what you know about how that system scaled, how soon is it before all of us can turn off whatever other television services we have, and every video is delivered through IP to everyone's home in the U.S.? I mean, I know that that's something that's coming at some point, but based on your experiences, what's the realistic time that you think that most of the major service areas could basically just convert to all IP delivery?
Yeah, so I mean, it's a good question. Obviously, everything has some sort of like a timeline, right? And then, so there are technology hurdles, first of all, right? There are some physical hurdles, and then obviously there is this perception, right? What are people gonna think? What are the content producers, the content distributors, what are they gonna think, right? So I would say from a technology perspective, we've come a long way, right? If we can do this, we can certainly experiment on other things, right? From a physical limitations perspective, again, with the new technology, we've overcome a lot of those, right? And it's really, I mean, I think in my opinion, this is a pretty cool idea. Not to brag about myself, but yeah, my friend Con Wilms worked on it. It was great. So and customers who've actually looked at it and really liked it and are looking into putting it into production. It's going to be a challenge in terms of overcoming some of the perceptions that people might have in terms of, okay, you know what, how is it really gonna go? So we'll see. We'll start with one, and kind of go from there. I don't unfortunately really have a specific timeline, but I guess that would be my process of thinking here.
All right. Excellent.
Thanks, everybody.
Thank you.